If the universe is full of life, then silence may not mean we are alone. It may mean we're being left alone. Or worse, that we're on display. If the universe is as vast and ancient as it appears to be, then one question should echo louder than all the rest. Where is everyone? This question sits at the heart of what we call the Fermi Paradox, the tension between what the universe seems to permit and what we actually observe. On the one hand, the galaxy contains hundreds of billions of stars, many older than our Sun, many surrounded by planets. Earth-sized worlds in temperate orbits appear to be common, not rare. Life on Earth emerged almost as soon as conditions allowed it, and while intelligence took longer and proved more fragile, it still arose. None of this appears exotic or unlikely in hindsight. We've spent entire episodes exploring how life might exist under chemistries and conditions we personally could not survive for more than moments. And yet, when we look into the cosmos, we see no obvious signs of anyone else being there. No alien megastructures dimming starlight, no artificial infrared glow from waste heat, no unmistakable radio beacons sweeping the sky. The stars look natural, the galaxy looks quiet. Too quiet. That silence has inspired many explanations. Perhaps intelligent life is extraordinarily rare. Perhaps technological civilizations tend to destroy themselves shortly after developing advanced tools. Perhaps interstellar travel is simply too difficult or too slow to be practical. Each of these ideas has merit, and none can be dismissed outright. But today we're exploring a very different class of answer, one that assumes intelligent life is neither rare nor fragile, and that interstellar expansion is not fundamentally impossible. What if the galaxy is full of civilizations, and the silence we observe is not a failure to exist, but a choice? This is the Zoo hypothesis. The Zoo hypothesis and time asymmetry. First proposed in the 1970s, the Zoo hypothesis suggests that advanced extraterrestrial civilizations may deliberately avoid contact with the emerging ones, much as humans isolate wildlife preserves or restrict interaction with uncontacted tribes. In this view, Earth is not overlooked or ignored. It is being left alone. The comparison to Star Trek's Prime Directive is unavoidable and useful. A policy of non-interference with civilizations not yet capable of interstellar travel. But the Zoo hypothesis is broader than that. It doesn't require benevolence, only restraint, and it doesn't require us to be special, only young. That last point matters more than it seems. Our Sun formed billions of years after the Milky Way's earliest stars ignited. That means there could be planets elsewhere with a head start measured not in thousands or millions of years, but billions. All of recorded human history fits comfortably inside the last 10,000 years. Modern industrial civilizations are barely 2 centuries old. If a civilization rose even 1 million years earlier than us, a trivial margin in galactic terms, it could have reshaped vast portions of the galaxy by now, even using conservative, sublight technologies well within known physics. You don't need fast-light travel to settle the Milky Way. At modest fractions of light speed, a civilization can cross the galaxy in a few 100,000 years. Given enough time, they could revisit every star system many times over, settling or restructuring any region they cared to. And as longtime viewers know, settling doesn't mean terraforming planets. Space habitats are far more efficient, scalable, and flexible. You don't need Earth-like worlds. You can live almost anywhere, including places traditionally considered dead real estate, like white dwarfs, or even near black holes. Which brings us back to an old problem. The Dyson dilemma, reframed. If you could build one large space habitat, you could build many. And if you can build many and you choose to grow, you'll eventually surround your star with them. That is a Dyson swarm, not a solid shell, but a dense cloud of energy-collecting structures, habitats, and other megastructures that intercept a significant fraction of a star's output. Such a civilization becomes Kardashev Type 2, and in doing so, creates an unavoidable signature: waste heat. Energy use demands heat rejection. That heat must be radiated away, typically in the infrared. A galaxy filled with short-lived expansionist civilizations should therefore glow unnaturally bright in infrared surveys, and it doesn't. This is the Dyson dilemma. If advanced civilizations exist and expand, we should see them. Since we don't, something must be stopping that outcome. In earlier episodes, we explored multiple ways this dilemma could fail. Perhaps civilizations plateau at low energy use, perhaps they self-destruct, perhaps they abandon physical existence, perhaps expansionist civilizations are rare, perhaps growth is actively discouraged or prohibited. All of these remain possible. But today, we need to make explicit an assumption that usually remains implicit, that the universe we observe is genuinely real and not deliberately falsified. Heavy stealth and the expansion of the zoo. Once we consider the zoo hypothesis seriously, we have to acknowledge an unsettling reality, which is to say, for civilizations capable of galactic-scale engineering, altering our apparent reality may be trivial. To a Kardashev Type 3 civilization, one has already enclosed or reorganized much of its own galaxy, even something as extreme as surrounding an entire star system with interception, filtering, or projection infrastructure would be well within reach. And they wouldn't need to fake everything. They could interfere locally instead, filtering signals our telescopes receive, manipulating our probes, or altering the data streams sent back by astronauts, who they mind-wiped. That would be far more subtle than blocking starlight and likely far cheaper in energy and effort. Critically, either effort is trivial for them. At the more speculative end, they could place us inside a fully simulated environment, Matrix style, or exploit physics we don't yet understand to create a self-contained pocket universe, one where the zoo is not just Earth, but the entire observable cosmos available to us. If even some of those possibilities are on the table, then the absence of evidence stops being evidence of absence. It becomes part of the enclosure. This kind of scenario is essentially impossible to disprove. It isn't falsifiable in any practical sense, but it does tell us something important. If such civilizations exist, they are not merely hiding. They are capable of what might be called heavy stealth. Not the hide behind an asteroid and hope nobody notices kind of stealth, but brute force stealth, where you alter apparent reality so thoroughly that your existence never registers at all. That's the key twist of the zoo hypothesis. Unlike berserkers, the dark forest, or hidden alien empires, this is not driven primarily by fear of us. The premise is that they are massively more powerful, with vast resources to expend, and they are keeping us in the dark for their own reasons, whether ethics, containment, curiosity, or something stranger still. And that leads naturally to the next question. Whether we are dealing with mega civilizations in heavy stealth or more classic scenarios, we need to ask, who exactly are the Zookeepers, and why do they bother? So who are the Zookeepers? When people first encounter the zoo hypothesis, their instinctive objection is coordination. How could an entire galaxy full of civilizations agree to stay quiet for millions of years? On Earth, we can barely get a handful of nations to honor a treaty for a decade. The idea of a perfectly enforced, galaxy-wide non-interference policy sounds absurd. Until we realize that it doesn't actually require widespread agreement at all. The zoo hypothesis does not need thousands of civilizations cooperating. It only needs one that got there first. Time asymmetry matters enormously on galactic scales. The Milky Way is over 10 billion years old, while technological humanity is effectively newborn. If even a single civilization arose a few hundred million or a billion years earlier than everyone else, it would enjoy a staggering first-mover advantage. Given enough time, even conservative expansion at sublight speed allows a civilization to spread influence across the entire galaxy, not necessarily by colonizing every star, though they could, but by establishing presence, infrastructure, and enforcement capability wherever it matters. In that scenario, the Galactic Club doesn't look like a parliament, it looks like a legacy system. That lone ancient civilization would not need to micromanage every developing species, either those emerging from worlds it left alone or its own divergent kin and creations. It could set rules early, enforce them automatically, and let time do the rest. Any later civilizations will grow up inside a galaxy where non-interference is already a fact of life, not a debated principle. By the time they became capable of questioning it, violating it may be physically impossible or existentially suicidal. There's always the assumption that advanced civilizations behave like modern human societies. We tend to imagine aliens arguing, defecting, competing, and leaking secrets, because that's how we operate. But that may be a selection bias. Civilizations that remain biological, short-lived, and politically fragmented might simply not survive long enough to become galactic players. The ones that do persist are more likely governed by long-lived individuals, artificial intelligences, uploaded minds, or highly stable post-biological systems. Such entities probably do not think in election cycles or human lifetimes. They think in terms of orbital periods, stellar evolution, and cosmological horizons. To a mind that can slow its internal clock, pause indefinitely, or fork copies of itself for parallel analysis, waiting a million years for a civilization to mature is not patience, it's routine. From that perspective, the zoo is not fragile. It isn't maintained by trust or goodwill. It's maintained by inertia. And that's what makes it unsettling. If the zookeepers exist, they may not be watching us with curiosity or concern in a human sense. They may simply be executing a process that began long ago before Earth formed, a standing rule applied to any biosphere that hasn't yet crossed some invisible threshold. It also isn't enough to do the whole galaxy, because you could get intrusion from other galaxies who developed free from your initial dominant civilization, and at the same time, you also don't need to control the whole galaxy. A civilization that staked a claim on a small region of the galaxy we happen to be in might be in a good position to create a zoo around us that others stayed away from, or mostly did. They might not bother offending the local empire by poking their nose in, but might have some elements of their society that thought it right or fun to interfere, which even leaves room for the occasional interferences or anomalies that observers might interpret as UFO sightings, which, to be fair, is what they would be, which raises the next question. Why do they bother at all? Why build a zoo? If a civilization is powerful enough to enforce non-interference across interstellar distances, it must have a reason to do so, surely. And while science fiction often treats the zoo hypothesis as a single idea, it's really a family of motivations that can overlap, reinforce one another, or even contradict each other. The most benign motivation is curiosity. From a scientific standpoint, a naturally evolving technological civilization is an extraordinarily rare and valuable data set. Intelligence isn't just a matter of biology, it's culture, ethics, social structure, technological pacing, and failure modes. Once contact is made, that data is irreversibly contaminated. The moment aliens land on Earth or transmit unmistakable signals, our development path changes forever. Any conclusions about how intelligence evolves in isolation are lost. In that view, Earth isn't special, it's representative. One sample among many. And the correct scientific response isn't intervention, but restraint. Closely related to this is the ethical argument for non-interference. This is the familiar prime directive logic, but stripped of Star Trek's romanticism. Even well-intentioned interference can be destructive. Introducing advanced technology, external authority, or alien values to a young civilization risks cultural overwrite. You don't uplift a species, you replace it. From that perspective, autonomy becomes a moral good. A civilization's right to make its own mistakes, even catastrophic ones, outweighs the desire to help. Though I should note, it probably also precludes some of the sillier prime directive scenarios where they let a species go extinct because they don't want to interfere by stopping the asteroid that's aimed at their planet. And that logic might extend to protecting us from alien fleets that would like to attack us, conquer us, or even just meet us and trade with us. The zoo is not really a cage for our protection, but a buffer protecting our developmental integrity. But ethics and curiosity do not have to be the whole story. There's also paternalism. A sufficiently advanced civilization might view emerging technological species the way we view adolescents, capable of remarkable creativity but dangerously impulsive. The period where a species gains access to nuclear weapons, biotechnology, and artificial intelligence before mastering global coordination is a narrow and perilous bottleneck. Left entirely alone, many civilizations may not survive it. In this version of the zoo, intervention happens, but invisibly. Extinction-level events are quietly prevented. Rogue asteroids are nudged aside. Nuclear wars are subtly diffused. Pandemics fail at the last moment. The zookeepers don't teach us how to solve our problems. They simply ensure we live long enough to solve them ourselves. Too much protection, however, creates another problem. While an overwhelming threat may need to be dealt with, a species is never allowed to fail, never develops resilience. A perfectly safe environment is a comfortable cage, and still a cage. So even benevolent zookeepers may deliberately allow near disasters, stepping in only when the alternative is total extinction. And then there's the darker motivation: containment. Not every emerging civilization is benign. From the outside, Earth may look less like a curiosity and more like a potential hazard. Expansionist ideologies, uncontrolled self-replicating technologies, or value systems incompatible with the broader galactic stability could justify quarantine. In this scenario, the zoo isn't about protecting us at all, it's about protecting everyone else from us. The unsettling part of that is that all these motivations can actually coexist. A civilization might be curious, ethical, paternalistic, and cautious all at the same time. The zoo hypothesis does not require aliens to be benevolent or malevolent, only rational, mostly, long-lived, and capable of thinking on scales where patience is cheap and intervention is optional. And if such zookeepers exist, the real question isn't whether they could hide, it's how they enforce it. Enforcement: how the zoo is maintained. The zoo hypothesis lives or dies on enforcement. Curiosity and ethics explain why a civilization might choose non-interference, but they do not explain how that choice survives contact with reality. On Earth, even simple rules erode over time. Accidents happen, dissidents appear, someone always breaks protocol. So the galaxy really is a zoo. Something must actively prevent leakage. The key realization is that enforcement does not have to be social, it can be physical. Once a civilization reaches a certain technological threshold, it does not need consensus to enforce rules, it needs infrastructure. Automated systems don't get curious, greedy, bored, or sentimental. They don't leak secrets or change their minds. If sufficiently advanced civilization sees the galaxy early with enforcement mechanisms, those systems could operate indefinitely with minimal oversight. This is no easy task to set up and maintain without critical violations, but as we saw in our Ancient Machine Monitors episode, it can probably be done. One common proposal is the idea of lurker probes, dormant sentinels parked in the outer reaches of a developing star system, perhaps in Oort clouds or Kuiper belts, where they are cold, dark, and extraordinarily difficult to detect. These would not be observers in the human sense. They would be gatekeepers. Their role wouldn't be to study us in detail, but to monitor traffic, watching for incoming vessels, outbound expansion attempts, or unauthorized contact. If a rogue civilization tried to initiate contact, enforcement would not require a negotiation. A relativistic kill missile interceptor does not ask questions. At velocities approaching the speed of light, even a modest mass carries the kinetic energy of a planetary extinction event. You do not need fleets or wars, you need timing and automation. A single strike delivered early and decisively solves the problem. This does not require constant violence. The mere existence of such enforcement would shape behavior. Any civilization that discovered the rule and tested it once, fatally, would never try again. Some might, but as they say, repetition is the key to learning. Over cosmic timescales, that creates stability, not through diplomacy, but through natural selection. Only civilizations that comply survive. Rough stuff, but realistically, as we explored in Quarantined Worlds, if your goal is to keep a world off limits for billions of years, you need to be ruthless about it and not bluffing. In Star Trek, we do not see when the Federation tells the Klingons, Romulans, or Ferengi to stay away from some planet, or they'll be fired upon, and that's because the setting cannot permit that. Absent hand-wavium and a ruthless streak, there's also a softer form of enforcement: capability suppression. Rather than destroying violators, the zookeepers might simply prevent certain technologies from ever being deployed successfully within quarantined regions. Interstellar propulsion that fails mysteriously, communication attempts that never propagate beyond local space, expansion strategies that hit invisible ceilings. From the inside, it looks like bad luck or hard physics. From the outside, it's traffic control. The important point is that none of this requires constant attention from changing and fallible people or governments. Enforcement can be rare, surgical, automated, and mostly invisible. If the system works, it almost never has to act. And if you're inside it, the absence of action looks exactly like the absence of anyone else. Which brings us to the most counterintuitive idea of all. Maybe they're not hiding quietly at all. Heavy stealth. Hiding by overwhelming force. When we imagine stealth, we tend to think small, dark ships, quiet signals, careful avoidance. That's the kind of stealth practiced by weak actors trying not to be noticed. Truly advanced civilizations do not need to hide within reality. They can afford to reshape how reality is perceived. This is what I've taken to calling heavy stealth. The term started as a joke, partly inspired by the Venture Brothers' towering Watcher analog, who bellows at everyone, "Hey!" and partly by a running gag in my tabletop group about how my full-plate wearing, sun-emblazoned paladin kept succeeding at stealth checks somehow. We eventually decided the explanation was simple. Either everyone nearby was blinded and deafened by his arrival, or there were no witnesses left alive. Subtlety wasn't the point. Control was. That intuition turns out to scale remarkably well. Heavy stealth isn't about slipping through shadows or minimizing emissions. It's about altering the conditions under which detection happens at all. Instead of avoiding sensors, you redefine what the sensors are allowed to report. You don't dodge observation, you manage it. At the level of a Kardashev Type 3 civilization, this isn't speculative magic, it's logistics. If you can reorganize stars, you can certainly curate data. While you might do it if you could, the goal is not to fake everything everywhere all the time. It's to ensure that observers like us only ever receive outputs that look mundane, consistent, and uninteresting. Crucially, this reframes the problem. You do not need to hide megastructures in the literal sense. You need to prevent anomalous conclusions from surviving the scientific process. Each observation still looks reasonable. Each instrument still works. Each dataset still agrees with the others. But what never appears is the pattern that would force a revolutionary explanation. In that sense, heavy stealth operates upstream of discovery. It does not fight telescopes, probes, or theories individually. It constrains the space of conclusions that can ever be reached. From inside the system, the universe doesn't look censored. It looks boring. At the far speculative edge, this logic extends beyond information control into environmental control. If a civilization can manipulate space-time itself, then the boundary of the zoo need not be planetary or even stellar. It could be causal. In such scenarios, the enclosure is not Earth, but the entire observable region available to us. Anything beyond that boundary never enters our light cone, not because it's hidden, but because it's structurally inaccessible. This is where the zoo hypothesis becomes deeply uncomfortable, because it brushes up against unfalsifiability. If the concealment is total, then the absence of evidence can always be explained away as part of the mechanism. That makes it a poor scientific hypothesis, but a powerful philosophical one. It forces us to confront how much of our confidence rests on the assumption the universe is not actively curated, that seeing is believing, and that we should believe what we see. Heavy stealth also sharpens the Dyson dilemma. The dilemma assumes that growth inevitably reveals itself through waste heat and large-scale engineering, but that only holds in the absence of active suppression. A civilization capable of stellar engineering is also capable of preventing the consequences of that engineering from being visible to selected observers. At that scale, stealth isn't delicate, it's brute force. And unlike Dark Forest or Berserker scenarios, none of this requires fear on their part. The Zookeepers don't need to be worried about us. They only need to find non-interference cheaper than engagement and containment easier than cleanup. Heavy stealth isn't paranoia, it's administrative efficiency. Which leads us to the most unsettling question of all. If we are inside a zoo, how would we ever know? That's where the problem stops being astronomical and starts being epistemological. Cracks in the glass. Can the zoo be detected? No enclosure is perfect. Physics is unforgiving that way. The zoo hypothesis survives only as long as the illusion holds, and illusions, no matter how advanced, must spend energy to exist. That energy leaves traces. It produces heat. It disturbs space-time. It introduces asymmetries. And if it's none of those by some advanced clock tech, then it probably produces other things you could detect, even if you need that clock tech to do it. Whatever advanced technology you use for stealth, there is probably a same application of that technology that makes it detectable. Now, you can hide light fairly easily if you are powerful enough. You cannot hide gravity, entropy, or information loss without rewriting the laws of the universe themselves. Well, that's where the cracks begin to form. One of the most promising avenues is gravitational astronomy. Unlike electromagnetic signals, gravitational waves cannot be reflected, absorbed, or spoofed in the usual sense by any physics we know. They are ripples in space-time itself, produced by the motion of mass and energy. The advanced civilizations are moving stars, constructing megastructures, or operating enforcement systems involving relativistic masses. Those activities generate gravitational signatures whether they want them to or not, and we are only just beginning to listen for them. Detectors like LIGO, Virgo, and the future space-based observatories such as LISA will allow us to map the universe not by light but by motion. Over time, we will build catalogs of what natural gravitational activity looks like: black hole mergers, neutron star inspirals, cosmic background noise, anything that deviates from those patterns, regularity where chaos is expected, precision where randomness should reign, all becomes suspicious. And remember, even if a species should at some point get technology that might cover such things over, there should have been a period of time when they, or some other species, utilized that technology before they had a way to hide it. Those fingerprints should still be visible. Much like our radio waves will still be visible to anyone even should we stop using them because they've already left the planet. Too late to hide. Another avenue is thermodynamics. Even heavy stealth can't cheat the second law forever. If energy is being used on a galactic scale to maintain illusions, intercept signals, or enforce quarantines, waste heat must emerge somewhere. It doesn't have to appear near us, but it has to exist. As our infrared surveys improve and begin mapping entire galaxies across time, we may notice something odd. Not bright anomalies, but missing ones. Galaxies that look too clean, too quiet, too well behaved. Then there's information theory. If reality is being filtered or curated, errors will cluster. Statistical noise will show correlations it should not. Independent measurements will agree too well. Randomness itself becomes suspect. A universe that looks always exactly as expected is not necessarily reassuring. It may be edited. This is the subtle irony of the zoo hypothesis. The more carefully maintained the illusion, the more artificial it risks becoming. Perfect camouflage stands out in a messy universe. And then there's us. Our technology is evolving rapidly, not just in sensitivity but in diversity. We do not observe the universe in one way anymore with telescopes or our eyes. We cross-check across wavelengths, messengers, methodologies, optical, infrared, radio, neutrino, gravitational, independent pipelines, independent instruments, independent nations. Each new channel multiplies the difficulty of deception. You can't just bribe or trick or threaten leaders of one country. You have to bribe, threaten, or trick all of them. They may have tech that lets them spoof gravity waves, for instance, but do they have everything locked up over dozens or thousands of different potential holes in their masquerade? Think about how you go about hiding a major metropolis. The zookeepers don't have to fail everywhere. You only have to fail once. Today we're asking whether we might already be observed and not just aware of it, and if that feels unsettling, consider how much of our own planet remains mysterious. Gods and Monsters from Curious Archive explores deep ocean life that often feels more like mythology than biology, ancient creatures and environments we barely understand. It's a useful parallel for thinking about unseen observers, and how much can exist without being noticed. And closer to home, my monthly exclusive, Surviving a New Ice Age, explores how humanity might endure when our own environment becomes unfamiliar again. Nebulas where every episode of SFA appears early and ad-free, alongside years of monthly exclusives and content from hundreds of creators. Right now, Nebula is offering 40% off lifetime access. Just $300 for permanent access to everything on the platform. Or you use my link on the QR code to get 50% off an annual plan. That's just $30 for the whole year. Leakage, accidents, dissidents, and the cost of perfection. Even if the enforcement systems are flawless, the zoo hypothesis still has a human problem, only it isn't human. No civilization is perfectly uniform. No intelligence, no matter how advanced, is guaranteed eternal consensus. Over millions or billions of years, dissent becomes inevitable. Someone will disagree. A scientist who believes contact is ethical. A philosopher who sees isolation as cruelty. An engineer who thinks the experiment has run its course. Or simply a bored post-biological mind looking for novelty in a universe that has grown quiet and cold. All it takes is one. This is the leakage problem, and it's the strongest internal challenge to the zoo hypothesis. Not because enforcement fails often, because it doesn't need to. A single unauthorized probe, a single unfiltered transmission, a single artifact left behind in the wrong orbit. Any of these could shatter the illusion permanently. To prevent that, enforcement must be absolute. That implies something unsettling. The zookeepers don't just monitor us, they monitor each other. The same systems that keep younger civilizations quarantined must also suppress rogue actors within the advanced community itself. Since you have to maintain resolve over geological timescales, you must be willing to find a way to make sure your society never changes its mind, or that you have automated systems willing to fire on your own ships if they decide to send a fleet to a previously quarantined world. So the zoo isn't just a preserve, it's a prison with outward-facing bars. Now this all begins to resemble a less benevolent galactic club and more hegemonic order, an ancient, automated regime that enforces stability by removing freedom. Not because it is evil, but because over cosmic timescales, freedom is dangerous to its objective. At that point, the zoo hypothesis starts to converge with other ideas we discussed before. The alien court war, dormant alien empires, machine custodians maintain long-dead values. The silence is not kindness, it's inertia. And inertia can last a very, very long time. But it isn't infinite. Every generation of human technology increases the cost of containment. Each new sensor, each new observatory, each new probe that leaves Earth adds complexity to the illusion. At some point, maintaining the zoo becomes more expensive than dismantling it. That's when the hypothesis flips. The zoo is not a permanent state, it is a phase. And like all phases in cosmic history, it ends not with an announcement, but with a failure, a missed anomaly, a delayed interception, a signal that slips through. Which brings us to the most dangerous idea of all. What if the zoo isn't breaking because we are ready, because the zookeepers are no longer able or willing to maintain it? Graduation or exposure, how the zoo ends. If the zoo hypothesis is correct, then it cannot be permanent. Not because we rebel against it, and not because the zookeepers grow careless, but because containment becomes progressively harder as a civilization matures. The younger species don't need to surpass the zookeepers technologically, it only needs to become difficult enough to manage. Time erodes their willpower and capability to keep the quarantine, while enhancing our ability to pierce it. Humanity is already on that path. Every improvement in our observational tools widens the surface area of the enclosure. We don't just look at the sky anymore, we interrogate it. We can compare signals across instruments, across wavelengths, across continents and orbital platforms. We measure not just light, but timing, polarization, spectral consistency, and gravitational behavior. We monitor space-time itself. We run simulations and check them against reality in thousands of independent ways. From the perspective of a hypothetical zookeeper, this is a rising maintenance cost. At some point, one of three things will happen. The first possibility is graduation. The zoo ends because it has achieved its purpose. Humanity reached a technological and cultural threshold where continued isolation is no longer justified, or no longer useful, or no longer sustainable, or some mix of all of the above. In Star Trek, they use the invention of warp drive as the cusp. presumably not out of any particular belief that this piece of technology makes you awesome and enlightened, but more recognition that with it, the illusion of solitude is bound to end in the near future. So the illusion is dropped deliberately. Contact occurs, not as a revelation, but as an induction. The preserve becomes a neighborhood. For us, it might be Kardashev 1 status, a recognition that the cage will be too difficult and too big to continue and is no longer needed. This is the most optimistic outcome, but also the most demanding. It requires not only technological maturity, but ethical and institutional stability. A civilization trusted with knowledge of a wider, potentially dangerous cosmos must be capable of restraint, cooperation, and long-term thinking. Graduation is not a reward for cleverness, it is a test of responsibility. The second possibility is exposure. The zoo ends because the illusion fails. A signal slips through. An anomaly resists suppression. A gravitational signature doesn't match any natural explanation. A probe is discovered where no probe should be. In this scenario, contact is not planned, it is forced. And there is an ethical motivation for this too. One of the Watchers decides that some plague or threat running through them is too much, too likely to wipe them out without intervention, and it goes down to help. They don't care that they'll be punished, even executed, because as far as they're concerned, having an epitaph on the tombstone that reads, "I died to save a billion people," is worth it. Now the Zookeepers must choose between escalation, retreat, or acknowledgement. This is a messier outcome. It risks panic, misinterpretation, and conflict born of asymmetry. It is the cosmic equivalent of a locked room discovered by accident, not invitation. The third possibility is the quietest and perhaps the most unsettling. The zoo ends because no one is left to run it. The custodians go extinct or throw down their swords and shields in frustration and futility. The machines decay. The ideology that justified isolation erodes over time. The system remains, operating on inertia, enforcing rules long after their creators are gone. Eventually, entropy wins. The enclosure weakens, not through rebellion or discovery, but neglect. In that case, the silence does not break with a voice. It simply stops being enforced. What it means if we are being watched, or never were. Here's the uncomfortable truth. The zoo hypothesis is compelling not because it is comforting, but because it is compatible with everything we see. It explains the silence without requiring despair. It allows for a universe full of life without demanding that it rush to greet us. It fits a cosmos governed by long timescales, extreme power disparities, and conservative decision-making, and it does so without violating known physics, only stretching engineering to absurd but not impossible limits. That makes it dangerous. Not because it is false, but because it is unfalsifiable in its strongest forms. A perfect zoo explains any absence of evidence by definition. That makes the hypothesis to be handled carefully, not embraced casually. Which is why the most important question isn't, are we being watched? It's how should we behave if we might be. If we assume we are alone, the responsibility for the future of life in this galaxy rests entirely on us. Our mistakes echo forward unopposed. There is no one to intervene. If we assume we are being watched, then our actions are being evaluated, not for cleverness or power, but for judgment. How we handle our environment, how we treat one another, whether we choose cooperation over annihilation when given the tools to do both. Either way, the prescription is the same, and the idea of powerful watchers in the heavens above is not a new one to us. Build carefully, expand cautiously, learn restraint before capability outpaces wisdom. The zoo hypothesis doesn't absolve us of responsibility, it intensifies it. The bars are made of time. Whether the universe is a zoo, a wilderness, a simulated nursery from a later post-human era, or something stranger still, one fact remains unavoidable. We are early. We are a young technological species in an ancient galaxy. We are loud, curious, fragile, and accelerating. We are only just learning how to see the universe clearly, and how to survive our own power. If there is a glass wall between us and the rest of the cosmos, it is not made merely of force fields or projections. It is made of time, development, and trust. and those are things no one else can grant us. If there are zookeepers, they are watching a species in the middle of becoming something else. If there are none, then we are laying the first stones of whatever future civilizations will inherit, and may need to decide if we will be watchers of our own zoo for other younger civilizations one day. Either way, the silence is not the end of the story, it is the prologue. And whether we are eventually welcomed, discovered, or left entirely alone, the next chapter depends on what kind of civilization we choose to become. Because the bars of this cage do not break just when someone opens them. They break when the inhabitants no longer need them.